All right, so today we're going to be learning about space technology. So your goal for today and tomorrow is you should be able to obtain and communicate information to describe how data from technologies, so you need to know how telescopes, how spectroscopes, how satellites, space probes, and other space tools that astronomers use provide information about the objects in the solar system as well as our universe. So here's some vocab that you probably want to know. Might see some of this on the test. Probably next week, guys. So astronomers use telescopes, satellites, space probes, and spectroscopes to make observations and collect data about objects inside the solar system and outside of our solar system. All of these tools and the associated technology on them allow astronomers to analyze and interpret the data and help us learn what's out in the solar system as well as what's out in our universe. So the first type of space tool that you need to know about is a refracting telescope. So if you think way back when we did our waves unit, really wasn't that long ago, refraction means for light to bend. So in a refracting telescope, what we're using is a convex lens. So when the light enters the lens, the light bends, making the object appear larger. So it focuses the light through this top part. The light comes straight through, hits a convex lens here, hits a second convex lens here, almost like a giant binocular, and magnifies the image to your eye. So it bends and focuses light rays to produce images of objects in space. Refracting telescopes typically allow us to see things within our own solar system and can make some stars appear slightly larger. A reflecting telescope works very much the same way. We've learned a lot of the same things using reflecting and refracting telescopes. The only difference really between a reflecting and a refracting telescope is the word reflecting. So if you think back, reflection means for light to bounce off. So light enters the telescope at the top the same way, comes down, hits a mirror here, bounces back, hits a second mirror that's right here, and then the light comes out to your eye, so you look through the side of the telescope. This is the type of telescope I have. They both do the same thing. This curved mirror at the back allows the image to be larger, projects it to your eye, and you see a larger image of whatever it is you're looking at in the sky. Again, this is typically for objects within our own solar system. Radio telescopes are telescopes that are placed on Earth, and they receive radio waves. So if you think back to that electromagnetic spectrum, remember there's a whole range of things starting from radio waves all the way up to gamma rays. So radio telescopes receive radio waves that are emitted by different objects. These are a lot of times come from stars, very distant stars and distant galaxies. So this gives us a lot of information outside of our solar system and into the universe. Those radio waves are used to produce images. So we kind of like our cell phones where we send off the radio waves and then those radio waves can be reinterpreted into images. We can take the radio waves that are being transmitted by distant stars and galaxies and create an image of what that distant galaxy or star might look like. The good thing about radio telescopes, definitely write this down, guys, is that they can receive information in any weather during day or night. They are not blocked by clouds, or they can still work in the daytime. You can't use reflecting and refracting telescopes at daytime because it's too bright, so you can't see any stars. And you can't use them at night if it's cloudy because there's no light getting through to your telescope. There's lots of other types of telescopes out there as well that read other aspects of the radio's electromagnetic spectrum. So you can have infrared telescopes that read heat signatures. You can have ultraviolet. There's great ones on the sun. You should look up those. They're really cool. X-ray telescopes that look in the X-ray spectrum, and even some gamma ray telescopes. So all of those we can learn different things from. But all of these have to be placed outside of Earth's atmosphere. So these are typically located on satellites that are orbiting the Earth so that they can pick up those signals without any sort of blocking. So a satellite is an object that's placed in orbit around Earth with special instruments. So it could be an X-ray telescope. It might be a radio telescope. It might just be a regular reflecting or refracting telescope. But it could be any type of those kinds of tools that allow us to collect information from space, and then that information is sent back to Earth, typically through radio waves, and astronomers here on Earth interpret them. Space observatories are things like the International Space Station or the Hubble Space Telescope. These are instruments that have been launched into outer space. Again, they're typically orbiting, so they're typically also a satellite that collect information on distant planets, galaxies, and other celestial bodies. The Hubble Space Telescope is one example of a space observatory. The International Space Station is another example of a space observatory. And they all can just have different tools. So very similar to a satellite. Basically, mini satellites could also be considered space observatories. You guys are going to look up some information on the Hubble Space Telescope when you do your left page today. Space probes. Space probes are probably my favorite thing. I think they're the most interesting ones. These are probes that do not orbit Earth, but they go out into space. So these could be objects that are orbiting other planets, like the one you see here is orbiting Jupiter. There also could be ones that land on planets, like Curiosity or Opportunity, that are roaming around on Mars. Or they could be ones that are just sent straight off into space. For instance, we have Voyager 1 and Voyager 2. Those two are exploring the solar system, passing by planet after planet. I believe Voyager 2 is actually further than Voyager 1. You'll have to double check me on that, though. They were launched in the 1970s, and they still haven't made it to the edge of our solar system. So they've been out there for a long, long time. But space probes are essentially almost like satellites, but instead of orbiting, they're observing other planets and other objects in the solar system. The big thing with these, make sure you write this down. The reason we use space probes is because it's too far and too dangerous to send astronomers to those locations. And the tools on the space probes just depend on what the mission is. So like Opportunity and those have different tools than ones that are just orbiting a planet or passing by planets in space. The last major tool that you need to know about is a spectroscope. You guys have actually looked at a spectroscope. I walked around with one day in class. It was a little black tube, and I had you look at the light, and inside the tube, it had a little rainbow in it. So what a spectroscope actually does, it acts just like a prism. It has a diffraction or a prism in the middle, and it refracts the light into the colors of the visible spectrum. But the way that the bands are shaped, depending on how far apart each band is or what colors actually appear, helps astronomers determine what a star is made of. So the elements, think back to last year in 7th grade when you learned about the periodic table, what those stars are composed of. So if they have a lot of hydrogen or if they have mostly helium, which can also tell us how old a star is. So hopefully you've been able to obtain and communicate information to describe how those different technologies provide information. So you guys are going to get onto your left page. You're going to get a half sheet of paper from the substitute, and you're going to look up what we've learned from some of the different space tools that scientists use. Good luck, guys.